Geometry, Chapter 5, Review. We're going to be talking about centers of triangles. So let's begin with definitions. We have perpendicular bisectors. This is when a line passes through or to a midpoint of a side that is perpendicular to it. So what this means is this line cuts through this other line or meets this line at a 90-degree angle, and when it does that, it divides this line in half. We use perpendicular bisectors when we're finding the circumcenter of a triangle. So the perpendicular bisectors of the sides of the triangle are concurrent at its circumcenter, and it also creates some other properties. So let me get my pen out here. The circumcenter is where all three lines meet together concurrently. So we have three perpendicular bisectors, and as an example, you can see line M here splits this side in half equally, and it's 90 degrees. So when you were drawing this, you measured halfway and began to draw all the way across the triangle. You did that on three sides, and it created these points. But another thing that it did, and let me get my highlighter. It allows us to draw a line from the vertice to the point of concurrency, or the circumcenter, and each one of those lines is congruent to each other. So that means that CX is congruent to CY, which is also congruent to CZ. Altitudes. The altitude of a triangle is a segment that extends from a vertex and is perpendicular to the line containing the opposite side. So here are three types of basic triangles. And you can see in the first triangle, you can just drop the altitude down to the side and create a 90-degree angle. In the second triangle, it's a 90-degree triangle, so the altitude is actually the height of that triangle. And in the third, the obtuse triangle, there's no way to drop an altitude from a vertex inside, so we drop that altitude outside. So the altitudes can be inside, to the side, or outside of the triangle. These three altitudes drawn in a triangle create the orthocenter. The orthocenter are lines that contain altitudes, and they're concurrent at the, and they meet at the point of concurrency of the orthocenter. Now you only have two centers that you need to remember that have 90 degrees. We just did the circumcenter that has 90 degrees that splits the sides, and the orthocenter that has 90 degrees, but the point of concurrency, unless the triangle is equilateral, will not be in the same spot as the point of concurrency for the circumcenter. We have angle bisectors, and you should know well by now what this is. This is when we draw a ray in between two rays of an angle, and we create a segment EP or segment FP that are the same distance from the sides. So it creates congruent adjacent angles. So using angle bisectors, these points will be concurrent at the incenter, and that point will be equidistant from each side of the triangle. So in this case, if we call the center O, PO would be congruent to NO, which would be congruent to MO. Medians. The median of a triangle is a segment extending from the vertex to the midpoint of the opposite side. So when we were constructing these, we divided the side in half, we got our midpoint, and we drew a line to the next vertex. This brings us to the centroid. The three medians of a triangle are concurrent at the centroid, which is 2/3 of the distance from each vertex to the opposite side's midpoint. So when you have a centroid, as an example, if we look at segment CZ, it creates a situation where GC will be 2/3 of CZ, and GZ will be 1/3. Hints. If you're having difficulty remembering what terms go with which triangle property, try making up a mnemonic. As an example, I found this one on the internet. There are tons of them, but an incenter uses angle bisectors. So if you take the first letter of incenter, angle, and bisectors, you have I am beautiful. Orthocenter uses altitudes, orange apples. Circumcenter uses perpendicular bisectors, so that could be a colorful, pretty, ooh, that should be highlighted there, sorry, bird. The centroid uses medians, so that could be a crazy monkey. You might want to use mnemonics that are all animals or all fruit or something like that. But it'd be worth your time to take a look on the internet and find something that really helps you to remember. So let's take a look at all of these centers together. We have the circumcenter, the orthocenter, the incenter, and the centroid. And what you need to be able to do before you take the quarter exam is to be able to look at one of these and tell what type of lines they have. Is it an angle bisector? Or is it a median? Or is it an altitude? Or a perpendicular bisector? And then name the type of triangle center. Here's a practice. Let's find CF if GC equals 17 and GI equals 14. So GC is in the lower left-hand vertex, G to C, which is the point of concurrency, and GI, which is this small segment. First thing you need to know are what types of lines are these. Well, look, they're at a midpoint and they meet at 90 degrees. So what kind of lines are those? They're perpendicular bisectors. The lines are drawn from the midpoint of the sides. They're perpendicular to the sides. They're also equidistant. GC is the same length as EC and FC. So if GC equals 17, CF is another one of those lines that's equidistant, so that means it's congruent to GC, so the answer is 17. Number 2, find EF, which is this total side here, if EC equals 17 and EH equals 15. Well, by looking at the points of congruence, you should be able to do this quickly. If you redraw your triangle, you'll see that this lower portion of the triangle is EF. EF equals 2 EH. EH is this segment right here. So if EH is 15, EF will be 2 times 15, which equals 30. Find CI, this short segment here, if CF equals 17 and IF equals 14. Right here. I suggest that you redraw the triangle. Find CI if CF equals 17 and IF equals 14. When we redraw the triangle, we have a 90-degree triangle. What happens then, and let me shift to my pen. CI will be this bottom length, and then CF is the hypotenuse, and IF is the height. And we have IF is 14, CF is 17. So we have two values in our 90-degree triangle. That means we can solve using the P theorem. And I've done the math for you, but hopefully you were able to identify that before you went on here to see the answer. But you end up with CI equaling the square root of 93, which is approximately 9.6. Find EC. EC is right here, which is 2x minus 3, and CF, which is 3x minus 10. Right there. And if you take a quick look at these, both of these are equidistant lines. And go ahead and pause the video and do your answer. So because these were equidistant lines, we know that we can set the values equal to each other. So EC equals CF, 2x minus 3 equals 3x minus 10, and if you combine like items, x equals 7. Find EF. EF, that's that long side again, if EC equals 13 and CH equals 5. So what we need to do is solve for this long side, which remember is half of the side. EH will be half of that long side. So we need to solve this triangle and then double the answer. So we solve using the P theorem, and we find that EH is 12. So that means EF would be 2 times EH, which is 2 times 12, which equals 24. Number 6, name a radius of the circumscribed circle. If you don't remember what circumscribed is, you need to look that up right now. And you'll need to do a visual for yourself, so I would draw a similar triangle and then circumscribe the circle. Pause the video and go on and check your answer. So circumscribed means outside, and the goal is to have the circle touch each vertex. What happens then is, if you can see this, you have your your center of your triangle that you've already determined, and you have 3 lines that are the same length that all go out to the end of the circle. These are your radii. So it said name a radius. There were 3 possible answers. You could have answered all. It would be CE right here, or it would be CF, or CG. Number 7. Find the diameter of the circumscribed circle if EJ is 8 and JC is 6. So diameter is 2 times the radius. Do you remember what this dotted line is? This is our radius. It's also the hypotenuse of our triangle. There's a right triangle right there with 2 sides that you have values for. So go ahead and solve for the radius and then check your answer. So if we go ahead and set up our right triangle theorem, set up our Pythagorean theorem, we have 8 squared plus 6 squared equals EC squared, and that's the hypotenuse. That will also be our radius. So EC will be radius squared. 64 plus 36 equals 100. EC, the square root of EC, equals 10. So you need diameter for the answer to this problem. So 2 times EC, or 2 times 10, will equal 20. So the diameter of the circle is 20 degrees. So once again, here are your drawings. You can find all 4 of these drawings together on the internet if you want to print them out to keep studying. But you need to be able to look at the drawings to be able to identify the types of the centers. Example, is it a centroid? And then what kind of lines does it use? I will be sending you some links on a video that will be Quizlet exercises that you can use to practice flashcards. If you have any difficulty using that program, it's a very basic program, but I would go ahead and also do, besides do the flashcards, I would do matching and then do the small test that's on there to see how well you're doing. Hope this helps. Contact me if you have any problems, and we'll talk to you again at Chapter 6 review.